Today we're going to continue our series on transitioning to Angular 2, and we're going to be talking about TypeScript. So previously, we took a hot towel project, John Papa's hot towel project, and we refactored it to use a component-based design. So we moved logic out of controllers and into component directives. If you missed this, the videos are available on YouTube, so please go ahead and catch up. Today we're going to be comparing the JavaScript code, the refactored hot towel project JavaScript code, to the equivalent TypeScript code for Angular 1. So let's take a step back for a second. Why should we bother refactoring our Angular 1 applications at all? Why would we want to use directives over controllers? Why use a component-based design? Why use TypeScript? Why not like ES6? And how does all of this help you get ready for Angular 2? Well, let's take a quick look at Angular 2, and I think that'll help answer some questions. So Angular 2 is a complete rewrite of AngularJS. It's very different. It's been rewritten from the ground up. It does not have controllers. It does not have scopes. An application is not a series of modules that are registered with Angular of different types. It is simply a component tree. And the code base for Angular 2 is written entirely in TypeScript. So why such a drastic change? Well, Angular is 6 years old. Web technologies have evolved a lot since then. When Angular was first created, it was built to fill a certain need that Google had at the time. And it grew, and people used it in ways that they never imagined it would be used. And as such, over the years, they've tried to improve it, improve performance, patch it as necessary without breaking it. But there's only so far that they could take it. And they realized that going forward, there's a lot of lessons they learned from AngularJS, and to really make a top-notch web framework, they needed to rewrite it and redesign it. And so Angular 2 is completely different. Now they can be written in JavaScript in ES5, but using TypeScript or ES7 features, or I'll call it ES6 plus maybe, will result in a much cleaner implementation. So let's take a look at an AngularJS example, a very simple application. Here we're registering our application called MyApp. We have a factory, MyService, with a getName function. We have a controller, MyController in this case, that calls that getName function on the service and populates a scope variable called name. And then we have a directive that accepts an attribute called name and plugs it into its template and prints out hello name. So you can imagine in the HTML that you'd have an ng app is equal to MyApp. You would have maybe a div that has a controller, like an ng controller attribute on it, where you have MyController defined there. And then in the scope of that controller, you'll have a my-dir like directive, and you'd plug in the name value from the controller scope into that directive, and you'd end up with hello world being printed out on the screen. So what does this look like in Angular 2? Well, Angular 2 takes a bit of a different approach. So using regular JavaScript, this application could be written in Angular 2 like this. So you'd have a service, which is a class. It has a getName function on it that returns a world. And then you have a component. You have your app component. And you define the component, like attributes of that. You describe it. You'd have a selector called MyApp. You specify that you want to be able to inject MyService into this component. Your view template right there, and then you'd have a class that represents that component, which is basic. In this case, it's just a simple constructor where you can inject MyService, call getName, and attach it to the scope. So still, nice and clean, a little bit more structured, a little bit easier to understand. But now let's take a look at the same example using ECMAScript 7. So again, you have a class, MyService. Now you can start using the class features that come along with ES6. You have a decorator on that service that describes it as injectable. And then you have a class called MyAppComponent. You decorate that with a component decorator, where you define the selector, a view decorator, where you define the template, and then again you have that constructor for the component where you can inject my service in and call it. So you can see how if you take a look at the JavaScript implementation, it basically tries to implement the ES7 way of doing it, but in a way that works with JavaScript. Since JavaScript currently does not support decorators or classes, it has to use this syntax of providing ng class and like ng.view and .component. So what does TypeScript bring to the table? Well, we'll take a look at the TypeScript example, and it looks pretty much like the ES7 example. Again, you have a class that is a decorator that describes that as injectable. You'll see a couple minor changes. In this case, getName, we are actually explicitly defining the type that it returns. So it returns a string value. If we go down a little bit further, in myAppComponent, we have name defined as a string now. And you also see we don't need that @inject like decorator on the myService parameter in the constructor anymore. Since TypeScript is strongly typed, Angular 2 knows that you want an instance of myService and automatically injects that for you. So, but still very similar. Just the only thing that's added in there are types. So ES6, ES7, ES6 isn't even out yet, so why are we talking about ES7? Well, ES6 introduces most of the things that are needed to work with Angular 2. It has classes, modules, provides a bunch of other stuff, arrow functions, destructuring, promises, iterators, and a whole lot more. A whole lot of neat stuff coming in ES6. But decorators, one of the key parts of Angular 2, is not a part of ES6. They're in the ES7 proposal. So even when the ES6 is fully adopted, you'll still need to use a transpiler like Tracer or Babel in order to support those decorators. Now, TypeScript is basically, according to our website, they describe it as a typed superset of JavaScript that compiles to plain JavaScript. So what that means is you can take JavaScript code, you can take like a .js file, just change the extension to .ts to indicate it's a TypeScript file, and TypeScript will be able to compile it, and it's totally valid TypeScript. So what are some of the features you get with TypeScript? Well, it includes almost all the features of ES6, plus a few additional ones, the big ones being decorators. But it also includes types, interfaces, abstract classes, generics, really those features associated with strongly typed languages. So what's the big deal? What does that give you over ES6 or ES7? Why would you want to use TypeScript instead of just using like ES7 like in a transpiler? Well, it really comes down to the benefit of types, and this is also why the Angular team went with TypeScript as well. So it ensures type safety while you're writing your code, so you get no runtime type errors anymore. It allows you to develop by contract, and the code is much more explicit and easier to understand. So let's step through those for a second. You think about type safety. In JavaScript, you can pass anything into any function. So even if you write a function expecting a string to be passed in, you can pass in an integer, and everything will be fine. But then at runtime, if you're trying to call a function on that parameter that exists for a string but doesn't exist for an integer, then or a number, then you're going to get a runtime error. And these are popular bugs, I guess we'll call it, that people have in their applications when using JavaScript, because it can be hard to make sure that you're writing that the code you write is type safe. So it allows you to develop by contract. So what does that mean? Well, with types, you can define interfaces that explicitly define what an object or a function or a class should look like. So for example, if you have a function that accepts a config object, let's say, and this is a popular pattern, someone pass in like a config object, and that object contains certain parameters, certain configuration fields. Well, in JavaScript, you have to kind of go take a look at the function and see what fields it's expecting in order to know that in order to know what you need to pass in. And if you have a typo or an error in what you're passing in, you won't know about it until runtime. Well, with interfaces, you can actually explicitly say, I want an object that has these 3 fields are required, these 2 are optional, this is what our code's expecting. And if you don't provide something that matches that interface, TypeScript at compile time right away will tell you that you have an error in your code. So you don't have to wait till you get it all the way deployed out and have some one-off use case end up breaking your application. And then finally, the code is more explicit and easier to understand. And the same example, if you know what object you need to pass in, what that object should look like, it makes your life easier as a developer using, calling someone else's function. Now the nice thing about TypeScript is it's very flexible, so you can still take advantage of JavaScript's dynamic typing. You can define a type as a string, a number, or like an array. But you can also use the any type, which basically means that it can accept any value. So you can set it to a string value initially and then set it to a number later, just like you can in JavaScript. You can also define multiple types that can be accepted by a field. So in this example, we have is enabled, and we're saying that it can be either a Boolean or a number. So you can safely set it to a Boolean value like true or a number like 1, but if you set it to the string true, then you'll get a compile time error from TypeScript. So let's go back and take a look at that Angularjs 1.x example. And we've broken it out slightly differently. So rather than have all of the inline functions, we've actually broken them out into explicit functions. And you'll see why in a minute, so you can compare it to the same code written in TypeScript. So again, we have a service, we have a controller, we have a directive, and we register all of those with Angular as part of my app. So if we take a look at that same example in TypeScript, you can see it's really not much different. Instead of defining a function, we're defining classes. So my service, instead of being a function, is now a class. Instead of being a function that returns an object, it's a class that, when you call its constructor, will generate that same object. So it has the same getName function on it. My controller, again, previously you saw we were attaching things directly to the controller. It was a constructor function. Now it's a class, and the constructor itself is defined within that class. And the directive, again, instead of returning an object, again, we're providing a class with all the fields of the object that was previously returned. And then Angular knows how to handle these classes, since they're really just, when this gets compiled down to JavaScript, it's going to look very similar to this JavaScript code. And so you can see it's pretty clean. So not a big jump from from JavaScript to TypeScript. So let's take a look at some actual TypeScript code out there in the wild. So the first one we'll look at is the Angular 2 code base. So Angular is completely written in TypeScript. So so you can come here, take a look at how the Angular team has actually created their directives. Use that as a template for your own as you work with Angular 2. So let's go and take a look. Actually, go in modules to core directives. Let's take a look at the ng class directive in Angular 2. So here's what the TypeScript looks like. You've got, like TypeScript supports modules. So up top here, we're explicitly pulling in specific functions and classes from a module. Pull those all in. In some cases, we're pulling in interfaces. So you can define exactly what it is that you need, just like using require. So now they're defining their directive here. So a directive in Angular 2 is very similar to a component. In Angular 1, you can think of directives as being of 2 types, really. You can have a decorator directive that is an attribute on an HTML tag, so it decorates that element. Or you can have a directive be an element itself and have its own like HTML template. So in Angular 2, they've split those off. A directive is the equivalent of a decorator directive in Angular 1, so it just decorates an existing element. And a component has its own view and is essentially an an element directive in Angular 1. So here, again, we specify the selector, the inputs. You can see you have private like attributes. That's another nice thing about TypeScript is you can maintain, you can encapsulate data within classes, so you're not exposing it. You can hide that information. So with these private fields, if another TypeScript class tried to access them, then TypeScript would throw an error there for you at compile time, saying that those are private. There are some private attributes. We have a constructor. These private keywords in front of the parameters indicate that these will be assigned to private fields on the class. So just a little shortcut there. We have some setters. We explicitly set values for fields. We have do check and undestroy, some methods on there which actually fulfill, as you can see, this class implements do check and undestroy interfaces. So by having these two functions here, if you were to take one of those out, TypeScript would say that you're not implementing the undestroy like interface. And then we have private helper functions within the class that aren't exposed outside the class. So overall, if you've worked with Java or C# or any of those languages, then this should look very familiar. And you get the same benefits as you get from those languages. So that was an Angular 2 example. So let's take a look at the JavaScript version of the Hot Towel project that we had refactored previously and the TypeScript version. We'll take a look at what those look like side by side. So first we've got that one, then we've got TypeScript. So here's the JavaScript one. So let's go in and start taking a look at a few things. Let's go into the, actually, forgot we're on the wrong branch to be able to see those latest changes. All right. So if you go to step 9, that is the completely refactored version of this code base. So, and what we based the TypeScript application off of. All right, so let's take a look. If we're going to features, take a look at dashboard. We've got our dashboard controller here. So what does that look like in TypeScript? Dashboard controller, TS. So in JavaScript, which I'm sure most of you are familiar with this structure, we are registering the module app dashboard. We are attaching a controller to the module app.dashboard. The dashboard controller here will specify what we're injecting, and then we go in and we assign values to the scope, and like fairly straightforward. So if we look at the TypeScript version of this, it's a little more explicit. So we actually can define like an interface that says what the model should look like. So in this case, for our view, we're expecting a news object that has a string title and a string description. We're expecting a number message count. We're expecting a people array, and we're expecting a string title. And so then our dashboard controller can implement that model to make sure that what gets passed along to the view is actually there. You're not missing anything. We have our constructor function, which basically assigns some default values that are passed in and calls that logger info. So when we look at the other one, that happened in the init function before. And then we register the controller with Angular. So again, very similar, just a little bit different approach here. So let's look at something else here. Let's go into components. Take a look at, let's say, the people component here. So here's the directive for that. And if we look at the TypeScript equivalent, people directive TypeScript. So in JavaScript, we have a people directive that we are registering with Angular. We have a controller in that directive that we're not injecting anything into, and we have a click event handler here that just displays a window alert. It's pretty straightforward. We have an isolated scope with a people object on it, controller, controller as, bind to controller. So in TypeScript, we'll take a look. So again, we have our people scope. So again, that's like it's an interface defining what the scope should look like. And then we implement that down here when we define the scope. We have our constructor where we have an empty constructor because we don't really do anything when we're creating a new directive. And we have this instance function. And we'll talk about that in just a minute, but that returns an instance of the people class. So then down here, all those same attributes, bind to controller is true, controller as VM. We have a controller function, people controller, which is implemented down here. So again, very similar to what we see here. The people controller, has that click person, as we have here, click person, which calls the window alert, and then we register this. So one thing worth noting is when you register a directive, it's expecting an actual object. So in this case, rather than returning the people class and injecting people class in here, we're injecting an instance of that class. So we call, or we pass in a function, let me clarify. When you register a directive, what Angular is expecting is a function it can call that will return an object, an instance of that directive. And so we're passing along the function instance, which will return an instance of people. So that's, like we would keep going, but it would look pretty similar across the board, so we'll move on. So converting to TypeScript. So what do you have to do to actually make that conversion? Well, luckily, like I mentioned before, since TypeScript is a superset of JavaScript, the first step is just renaming your files to .ts extension, and then getting the TypeScript compiler to compile them to dynamically create those JS files. Then you can start refactoring your code. You can start adding types, classes, interfaces, all that stuff. So almost all major third-party libraries have type definition files. And what they do is allow you to pull in a JavaScript library, let's say like the Angular library or jQuery or whatnot, and know what the interfaces, know what types you should be using to call functions within that library. So for more information, you can go out to definitelytype.org. Like I said, almost all of all the big ones are out there, and they have this TypeScript Definition Manager, TSD command line tool, which you use kind of like NPM and allows you to configure your TypeScript project and automatically pull in those definition files that you need for your project. So really handy, really helps you get spun up quickly. And actually, let's take a quick look while we're here at what that looks like. So if we look at Hello World TypeScript, let's go back to the root here. So these are the typings. So in our index.html, for example, we pull in like jQuery.js or jQuery.min.js probably. So what this type definition file does is it basically has the API that you interact with in jQuery, but it's completely typed. So it's a bunch of interfaces. So the AJAX, like for example, AJAX settings. If you're just working with jQuery in JavaScript, all you know is the settings are an object, and you need to look at the documentation to see what fields are there. So what these type definition files is provide an actual interface that defines all the types and whatnot. So when you're writing your TypeScript code, it'll check against these type definition files to make sure that you're passing in the right values, the right types and whatnot, and it can give you that compile time check to make sure you're using the jQuery library correctly. So, all right, so moving on, learning TypeScript. There are the most popular resources that I've found for learning TypeScript. The website is fantastic. Take a quick look at that. They have a simple tutorial that you can step through, kind of a quick introduction. The handbook goes into a whole bunch of detail. All the basic types, interfaces, how to use them, examples. As you go through classes, modules, generics, all that stuff. So really great resource for learning how to use TypeScript. So what else? We have, so Pluralsight has some excellent classes. The TypeScript Fundamentals taught by John Papa and Dan Whalen, who is on the TypeScript team at Microsoft. TypeScript, like Angular with TypeScript, a great course if you want to learn, and a very new one on how to effectively write your AngularJS applications using TypeScript. And then John Papa has a Visual Studio Code course out here too, which is a great IDE for using TypeScript. And then edX also has a good in-depth course. This is taught by Dan Whalen, who's on the Microsoft TypeScript team. And this is a nice long course. Will go into a lot of detail. So these are some of the more popular ones. There's also various tutorials of, like online. Just kind of go out there and find what you want. But I'd start with those three sources. So the other nice thing that TypeScript provides is the playground. So if we go back to the TypeScript site, if you click on play up here, it loads up this playground. You can load up example code, so some examples of classes, generics, whatnot. But the nice thing about this is you can type in your own stuff here and, my class. And you'll see that as you're typing, it's compiling it into JavaScript, so you can see side by side the TypeScript code and the JavaScript equivalent. So great place to play around and really understand how TypeScript works and to understand the language. So some of the major editors out there that support TypeScript, these are probably the three most popular. Visual Studio Code, if you haven't used it yet, fantastic. It is a beta product right now. But one thing Microsoft has done well and has historically done well is IDEs. In this case, Visual Studio Code is not, don't think of it as Visual Studio. It is a simple editor, but it has some of those things that you love, like IntelliSense. They have some of the best, like autocomplete functionality in the business. And Visual Studio Code, since Microsoft developed this and TypeScript is a Microsoft product, it has fantastic support for TypeScript. So Sublime Text also has some plugins that will support TypeScript, and WebStorm as well. I believe supports it out of the box. So these are the three most popular ones. And that's all we've got for you today. So again, TypeScript is going to be a big part of Angular 2 and a big part of writing effective applications in Angular 2. So learning it and now will help you when Angular 2 is released, and converting your Angular 1 apps or building new ones using TypeScript will help you make that migration later. So thanks for joining us today. Stay tuned. Our next one will actually start diving into Angular 2. So you'll start to see why we took some of these initial steps, and we'll look at converting this Hot Towel project into an Angular 2 app. Thank you for joining us.